Hello guys, how are you doing? I'm super happy to be here. I would also like to thank you guys for subscribing to the channel. It has been growing quite steadily and I'm happy to see that. Now, let's just continue with our JSI module. So last time where we left when we created a very basic multiply function, and I would just like to continue that today. So there was one small detail that I forgot last time, and it's actually fairly important. It's actually very, very important, which is I forgot to move our lambda function from the context of our install function to the JavaScript context. Now, this is really important. If you have seen the C++ guide on the deallocation videos, then you know whenever whenever a C++ function finishes running, then its memory will get deallocated. So if you don't tell the compiler, or if you don't somehow manage your memory on the right way, then your function is just going to disappear, right? And this is a problem with lambda functions and with the JSI, because the compiler or C++ doesn't know how to copy a lambda function, right? There's no copy on value semantics. So therefore, we need to help the compiler a little bit, and after we have created our JSI function, we actually need to tell it, or we need to mark this chunk of memory for the function as movable, so it can be moved into the JavaScript context. So this is really important, and as well, when we create other JavaScript or JSI values and objects, we should also take care of moving them into the JavaScript context. Great, so let's just start by exploring the API of the JSI. I just refactored the code a little bit by moving the lambda into a different line, just because it will be easier to read for us. And I will just dive right in. One of the very interesting things about the JSI is that it's not very complex. You only need to understand that you are manipulating JavaScript from the host language, from C++. Right, so we will be creating all the JavaScript objects and values that we usually create. We just have to do it through the JSI. Now, I'm just going to take the function that we created last time, and I'm just going to go over some of the cases so we can explore all the API that the JSI gives to us. So let's say, for example, we have our multiply function, and what we wanted to do is to take two numbers and multiply them. So because JavaScript is a dynamic language, you can pass any number of arguments to any function whatsoever. It doesn't matter if the function uses them or not, you can always pass more of them. So one of the checks that you should probably do in your function is that you receive the correct number of arguments, the correct type of arguments, and so on and so forth, right? So these checks you need to do on runtime. You cannot enforce them on compile time. So let's say, for example, I want to limit my multiply function to 2 arguments. The question is, how do I validate them, right? How do I validate this condition? And then how do I tell JavaScript somehow that if something goes wrong? So the validation is fairly easy. I just need to check for the count, which is the size t. Again, we talk about the size t on the C++ videos, so I would recommend for you to see them. And we need to make sure it's not bigger than 2. If it is bigger than 2, then we will start using the JSI API. We basically go into the JSI namespace. There is a detail sub namespace, and inside there there's this function throw JavaScript error. Now, like I said before, we're gonna need to pass the runtime a lot with these functions. So the first argument is the runtime, and then finally we just pass a message for our JavaScript error. Now this is the pattern that's going to repeat throughout the JSI, where we are basically creating JavaScript entities by just passing or just somehow creating them on the C++ side, right? So all of this you can somehow translate to throw error blah, right? This is the equivalent JavaScript code. So we have first checked if we have the correct number of arguments. Now we need to check if they are actually the right type. So we're going to check for the first argument if it is a number. Now this, like I said, the JSI value is the superclass of all the possible JavaScript values that we're gonna get, and it does have a lot of convenience methods inside of it. Right, so you can check if it's a number, you can cast it to as a number, etc., etc. In this case, the one that we care about is the isNumber function, right? So this is just going to check if the value that was passed is a valid JavaScript number. So here we're basically saying if it's not a number, then once again, we throw an error. The next thing we want to do is to get our JavaScript number as a C++ value. Now we need to think JavaScript numbers are 64 bits doubles, right? So this means you cannot directly cast them as an integer, for example, right? And you also need to be careful about precision. If you need an integer from one of the JavaScript numbers, then what you need to do is first cast it as an integer. Be careful though, downcasting to a lower precision is going to lose data, right? So if your number has a decimal part or it's not exactly integer, you might have some rounding errors, you might lose the decimal part, and then you will lose some data. So this is something that you need to be careful about. We're going to do the same for our second argument. And now before continuing, and this is not related to our multiply function, I would just like to explore a little bit about the API for you to know it. So let's say instead of a number, I want my first argument as a string. So the way to get in string is first I call the asString method by passing the runtime. And then once again, we have to think the JavaScript strings, or any strings in a lot of languages, they do have an encoding. So we cannot just directly use a string. We first need to know in which encoding it's using. So usually it's going to be UTF-8, but it could use more encodings. Therefore, after I call my asString method, I need to call the UTF-8 method. And since we're dealing with C++, I'm using the string class from C++. Fairly straightforward. Now, let's say, for example, if my argument was an object, then I need to do another type of casting. And the interesting part here is that you're not going to be able to cast to a generic type, at least straightforward, because once again, JavaScript is a dynamic language. There is not such an equivalent on C++, right? Where you can just say, this is an object that holds a generic amount of data and arguments. So we're gonna have to stick with the JSI object class. Then I can simply call asObject on my argument by passing the runtime. And let's say, for example, if I have a JavaScript object that has a single property foo with the value 42 assigned to it, then this is going to be that object. Then I can, inside of it, call the getProperty method by passing the runtime and the key that I want to pass, and this is going to return 42, right? But be careful, once again, everything is wrapped, so the first thing that I'm going to get is a JSI value. And then if I want to cast it into a number and so on, we saw this how to do on the methods above. Likewise, I can set a property on my object. This is very similar to what we saw on the last video where we accessed the global context. This, once again, is just an object, right? Same as any other object. So I can call on it set property. I pass the name of the property I want to set, and finally a JSI value. For arrays, it's something similar. And once again, you have to learn a little bit about the internals of JavaScript. Basically, basically arrays are objects. So what we need to do first is cast our argument from a JSI value into an object, and the object can then be casted as an array. The array object is very similar to the object, but it does have some other convenience methods. For example, we can get the size of our array, and we can get a value at index. So I would recommend for you to just kind of explore a little bit. If you're using Xcode, it should be fairly easy because Xcode gives you auto-completion. So you can see we can do more checks. For example, if it's null, if it's undefined, etc., right? So, but it's not very complex. You can see these are just the basic JavaScript types. So we are just coding JavaScript or dealing with JavaScript through the JSI on the C++ world. Great. So I'm just going to comment this code. We don't need it. I just wanted to show you all the API. And after we have our arguments, we can finally do our C++ computation, right? So once I have everything in C++ classes and objects and values, I can just do my C++ normal code. In this case, it's just a simple multiplication, nothing too interesting about it. And I can save the result in an integer. So once I have my integer, now we kind of have to do the reverse operation of what we did here, which is creating JSI values. Now, the very nice thing about the JSI superclass is that it actually knows or will actually autocast based on which type you're passing. So if you're passing an integer and you just say, give me a JSI value with your integer as an argument, then this will automatically be converted into a number, a JavaScript number, right? It doesn't matter if here you pass a double or an integer, it will be converted into a JavaScript number. What happens if you want to, for example, create a null value? Then you have to use the null pointer, right? This will create a JavaScript null. What happens if you want to create undefined? There is actually one predefined constant that you need to use. What happens if you want to create an array? Then there's also the constructor for arrays, and here's one very important part. You cannot create dynamic arrays on C++, at least not very easily. If you create a JSI array, you need to create it with a fixed size. So in the next videos, whenever we're dealing with SQLite, we will actually create a vector, and then we will do the translation to an array. Unfortunately, I haven't found a better way of doing this. It does cost a little bit in terms that you need to copy the data, but we will see how to do this operation later. Now that we have the array, we can set a value on it by just calling the set value at index function. Once again, if you're using Xcode, you will get auto-completion, so you can see a little bit. There is multiple ways of initializing an array and some convenience methods in there, and so on and so forth. For objects is very similar, right? I can just create a JSI object, and inside of it I can just set the properties of my object. This will in fact create something like foo 42. So once you pass all these values into the JavaScript, they are just pure JavaScript objects, nothing too fancy about them. So then finally, after I have done my computation, I can return my result. So I'm just going to compile this, and then I am going to go into my SuperSQLite, into my JavaScript, and I will need to pass here, for example, 2 times 3. So if I have my application open, let's just give it a little while to compile. Sorry, you're not seeing my screen. it cannot find a variable. This is funny. So sorry, I figured out the error. So like I said, moving your memory chunks, managing your memory allocations, it's really important. Since I'm not declaring my Lambda function inline, it's not being automatically assigned or moved into the context of the JSI function. It's actually it remains in the context of this install SQL function. So one extra thing that I need to do, if I declare my Lambda function separately, I need to tell it or mark it as movable. So now if I recompile my application, then finally I get my result. If I change this code and if I call it with more arguments, then I should get my exception. If I change this and I say 10 and 2, it changes. Great, thanks a lot, guys. Today we covered a lot about the API from the JSI. As you can see, once you know how to create the JavaScript values, then it's just about manipulating or doing your C++ computation and then translating the result into JavaScript values. On the next video, we will start importing SQLite and we will start bridging the functionality of SQLite into JavaScript. And that's pretty much it. Hopefully afterwards you will be able to create your own JSI library. Thanks a lot for watching and please consider subscribing.